Hey guys, Dr. Mandis here. Hey, I want to pick up today where I left off in a hurry with in my last video. Talking about ionic compounds in water. Ionic compounds in water do something kind of unique, and it's called conducting. Okay, everybody thinks, not say everybody, a lot of students come into class thinking water conducts electricity. It doesn't. Okay, water does not conduct electricity, as any electrician will tell you. If you're working with water, with electricity, like in a damp basement or something like that, they always say in every video on YouTube, "Hey, you cannot be standing in a puddle." Okay, water like won't allow electricity to flow to ground; it'll block it. If you're in a bathtub and some electrical thing falls in, you conduct, the water doesn't. That's why you get shocked so bad. All right, so conducting is about electricity flowing through water. And I just said water doesn't conduct. Well, you can put stuff in the water that allow it to conduct. Okay? If that's the case, what things does allow it to conduct? Well, if they allow a lot of conduction, we call that a strong electrolyte. A little bit weak. Things that don't, no. Okay? You need ions to conduct in water. So strong electrolytes have a lot of ions. Weak electrolytes, not so much. Non-electrolytes, none at all. Okay, if it's an ionic compound that's soluble in water, you're going to get a ridiculous amount of ions, 100% dissociated. You're going to get a really strong electrolyte. Unless, of course, you barely put anything in there. But some covalent substances, like your weak acids and bases, partially dissociate and ionize in water, and they can conduct a little bit at a time. Okay, and that's like your vinegar, stuff like that. All right, non-electrolytes, if you put sugar, your covalent compounds into water, they don't conduct at all because they're covalent. They're not going to form any ions unless they actually undergo a reaction and become ionized. Alrighty. As a quick example, let's compare, just two sets of things and three examples: sugar versus salt, and then different concentrations of salt and different types of ionic compounds. Okay. The better conductor, and number one, is probably the sugar. Okay, I mean, the sodium chloride. Sodium chloride doesn't conduct. Okay, I mean, conducts. Oh my God, I'm messing that up. Sorry, guys. Sugars do not conduct because they're covalent. Salt, definitely going to conduct. Okay, now here's a gig. Which is the better conductor? Oops, meant to erase that. Which is the better conductor? Mesa salt or half as much? The mesa salt, 1 molar solution of salt, should conduct more than the half molar, okay? If sodium chloride dissociates, you have sodium chloride dissociating to sodium and chloride, then 1 mole of that is going to make 1 mole of cation and 1 mole of anion for a total of 2 moles. And that's where you get 2 molar. And that sort of math is in another video that I've done for you all, okay, on my channel. All right, so 1 molar will conduct more than a half molar. Well, okay, got that. What if it's 1 molar versus 1 molar? Well, these are soluble ionic compounds. They're definitely going to conduct. They're going to dissociate fully. Barium chloride looks like he's got 3 ions buried in there, 1 barium and 2 chloride. Sodium chloride still only has 2, so it's 3 versus 2. Barium's going to win that out. 1 molar barium chloride is really 3 molar ions. 1 molar sodium chloride is still the 2, so 3 beats 2. So the better, stronger conductor is the barium chloride. So that's it for conducting. Strong electrolyte, weak electrolyte. Some people call them a strong conductor, weak conductor. Conducting of metals would be different. Those are solids. Ionic compounds will only conduct as a liquid. Ionic compounds dissolved in water will conduct all the time. Okay, this is what we're talking about, conducting in aqueous solution. Strong, weak, not at all. This is Dr. Mandis. Have a lovely day. I'll definitely talk to you later. Take care.